So I'll be telling you about some IBL-inspired projects that I implemented in an applied statistics course a couple years ago. I'll start by telling you a bit about the course. It was numbered Math 3320 and entitled Applied Statistics. Here's the course description from our catalog. It's a first course in applied statistics emphasizing statistical thinking using real and computer-generated data. It was also a first course in applied statistics for me. That's not my background. I had never taken such a course, nor is it my field of expertise. So it was a first for both the students, unless they were retaking it, and certainly for me, the first time I was teaching it. The topics included data description and hypothesis testing using a variety of tests, z-tests, t-tests, chi-squared, linear regression and analysis of variation. And Minitab software was used extensively. I had never used this software either. It's exclusively for Windows, and I'm a Mac person, so I had to get special software to even run it. But essentially, if you've never used it, it's statistical software that looks a lot like Excel. It has sort of a spreadsheet front end, but with a lot more statistical capabilities than Excel. It's probably similar to SPSS, SAS, R, and other statistical software if used those, at least in terms of its capabilities. But for this reason, students taking this course receive our computational skills requirement given how much this software is used in the course. And the prerequisite for this course is Calculus 1, that's basically differential calculus, that we teach with a lab that introduces the students to Maple. Now, this is a prerequisite, but we do not use calculus for this course. It's not a calculus-based statistics course. In fact, it's only Calculus 1, so they don't even know, in theory, integration to be able to compute means and medians and probabilities by integrating a probability density function. This prerequisite's more in place for mathematical and scholastic maturity rather than actually using calculus or Maple for this course. As you might tell from the course numbering, it is a junior level course. It's a 3-hour junior level course. That's what the first two threes signify. And it's required for bioinformatics, biology, computer science, forensic science, medical laboratory science, and mathematics education majors. Obviously missing from that list is mathematics majors. It fulfills an upper division elective, but is not required for mathematics majors. Many graduate without ever taking this. So this course is primarily populated by upper division biology majors. That's one of our largest majors at the university, much more larger than those other majors listed on that second bullet. And the reason why it's required for them is all science majors at St. Edward's have to complete 2 years of research and then present their research in a senior seminar symposium. And biology majors in particular have to be able to analyze their research data, so that's why this course is required for them and similar majors. The average initial enrollment of 29 students makes it one of our larger classes at the university, and also presents some obvious challenges to using inquiry-based learning on a daily basis. That would be a rather large class size for a lot of those teaching techniques. So why try to incorporate IVL then in this course with a rather large class size, a highly prescribed syllabus? Well, this question might be obvious to this audience, but to sell it to the administration at St. Edward's, it's always helpful to tie it to the university mission, which says graduates in all programs should be prepared through training in critical and creative thinking, as well as moral reasoning, to analyze problems, propose solutions, and make responsible decisions. So I quickly learned being at a mission-driven university to get anything done to tie it to the mission statement. I am probably not qualified to help them with moral reasoning, but at least critical and creative thinking I think is right up our alley. In fact, it's right here on the website for the sponsors of this conference, that every student has the capability for creative and critical thinking. And in fact, the method pioneered by Moore has proven very conducive to recognizing, nurturing, and developing this ability. So I felt it was a natural fit to try to implement it. So the obvious question is how? As I said, this is essentially a service course with a highly prescribed and lengthy syllabus of statistical tests and techniques that must be covered. Primarily upper division biology majors. They're just trying to learn how to analyze their data. Large course, 29 students. But I'm not the first to recognize such challenges. In fact, one of Moore's students, whose name was already mentioned this morning and for whom there's going to be a couple tribute sessions Saturday morning, wrote that the term discovery learning is misleading. The student is not likely at an early stage to discover enough on his own to satisfy us in our attempts to cover the syllabus. A better term might be cooperative learning, with the instructor taking the lead. And as I said before, this was also my first course in applied statistics, so cooperative learning was especially relevant as I was also learning the material with the students that first semester I taught it. In fact, discovery teaching might have been a better title for what I was doing, as I was discovering what I was going to teach as I prepared each class. So the challenges are obvious here to how to implement IBL into such a course. But thankfully, Bill also suggested the solution in the same paper. One should not consider material covered until the students understand it well enough to apply it in new situations, which is very conducive to applied statistics. In fact, that's somewhat the point of the course, is to learn these methods and then apply them to new data sets in any scenario or context, specifically for biology majors, hopefully their own research. But going back to the mission of St. Edward's, we're trying to prepare students for the challenges of a 21st world and to confront the critical issues of society. So if you're wanting to tie it to that, they need to be able to apply the methods learned in this course to any of those challenges or critical issues. Who knows what they'll be. But the goal, of course, is for them to figure out how to do that by applying the methods from class to data of their choosing, like I said, perhaps from their own research or extracurricular interests. And then the data that they choose would determine which methods are appropriate, yielding highly individualized open-ended projects. They're all going to be different based on the data sets they choose. So I modified these projects from a Project Next session by Robin Locke, who will be giving the same session this August at MathFest in Hartford. So if you're affiliated with Project Next and think you might ever have to teach applied statistics without the relevant background, I highly recommend his session. It sort of saved my life. Or more specifically, my students. I guess I would have been okay, perhaps. So I modified 3 projects from Robin Locke. The first was on data description, displaying data and describing its properties, hypothesis testing, and linear regression. In the same Project Next session, Robin also presents some in-class activities that I think would be highly conducive to IBL activities. However, like I said, with the syllabus I was facing and the class size, some of those were more difficult for me to implement. So I focused more on out-of-class IBL aspects through these projects. The benefits were that it forced the students to think more creatively, more independently, and more in depth. As I said, the data set that they chose would determine the methods, so they're all going to be different, and they would have to figure out what methods were appropriate and what it told them about the data. So the discovery was supposed to be more about their data than the discovering the methods. That I think would have been a little more difficult to motivate discovery of. more realistic with real-world data. I was hoping that this would model what they might actually have to do, for instance, in their own research or careers. It allowed them to work in groups over longer periods of time than what would have been possible in the classroom. Hopefully more interesting, useful, and relevant if they chose data sets they really cared about or were important to them, rather than just finding something from the book. Less cheating. Every student's going to have a different project. And then my goal was that students would make it their own, take ownership of this project, given that it was their own data. I see that my formatting did change a little here. Some of the challenges I noticed in trying to implement this was that I didn't initially provide much control on the data they chose. So sometimes the data students chose, and I know I have a former student in the audience right now, so I'll be careful with what I say. It's not about him, I swear. Sometimes the data students chose were just inappropriate for the methods covered in the course, or for the methods that I was hoping that they would practice in that project. Sometimes they would get too creative with the methods or create new methods of their own, which made grading very difficult. There was a lot of variation from project to project. My initial goal was for the students to discover how the methods that we covered in class could be applied to their data set. And some students were really great about that and applied every single method, whether it was appropriate or not. Other students maybe just picked one method and then said, we're done, or created their own method. So it was really difficult for me to grade these fairly, since I left it so open-ended and asked them to discover how to use the methods from course and what it said about their data. So I couldn't really take off points for them getting creative on those aspects. So in my revisions the second time I assigned these projects, I tried to emphasize their creativity came from the data set they chose, and that they had to use the methods from class, but comment on whether or not they were appropriate and what it told them about their data. So I tried to separate the open-ended aspects from what they had to use from the course to what it told them about their data, and make the discovery more about their data rather than discovering new methods of statistics all by themselves. So I apologize for the font on this. I also have a couple PDFs that'll make it a little easier to read, but real quickly, the preamble is instructing them how to choose their data, that it should be important to them, and sort of describing what's expected, how many variables, how many should be quantitative, how many should be categorical, how many cases they should have, and then an introduction, the data itself, so on, histogram, box plot. So this is telling pretty clearly, these are the methods I want you to apply from class, but then each one ends with describe what it tells you about your data, explain whether it's appropriate for your data, and then the conclusions really reiterates what have you discovered about your data. Again, this is modified from Robin Locke, so I should give him ultimate credit here. But I think I'm out of time. Here's my email address. If you would like to see the other two projects that I mentioned, I'm happy to share those with whomever. Thank you.
How did you have students present their results to each other?
Yeah, so I think that's also a benefit of applying projects in general, is it gives students a lot of formats to I guess present their work. So Oral presentations were a component if they wanted to present to the class. Nobody chose to. There was the written report that I just outlined. When students worked in groups, ostensibly they were working through the project together and presenting to each other. With enough class time, I would have required an oral component for all of them, because that was ultimately, what I just showed you was a very abbreviated, but the longer version of the project made clear that what I was hoping is something that would catch the interest of a casual newspaper reader like the USA Today graphics or somebody surfing the internet. So an oral component like a 5-minute presentation, like why should we care about your data and what did you learn about it and what conclusions, sort of like a briefing they might have to give either for their research directors or careers eventually. Not sure if that answers your question, but yeah, that was one thing. So in the revisions to try to make these projects a little better at achieving the objectives for the course, I created a pretty uniform rubric for grading, and that would be something where the oral component would have been a part of.
So I'll be teaching a course where statistics and probability plays just a small part of the course. Like, what was the startup time in terms of the software, and also, like, do you see these projects as useful for like a part of a larger course that covered maybe other topics as well?
Oh, definitely. So the first question you're asking about, how difficult was it to learn Minitab? I'd say it's not the most user-friendly, and students did have a lot of issues with it. Once they got the hang of it, it was pretty straightforward. Some tried to just use Excel, and Excel could do a lot, and I think that's a format they're a little more used to. I'm not sure how it compares to SPSS or SAS or R or some of the other. I know there's one called StatCrunch, which I think is probably a little more conducive to students. Your second question is, could this be tied into other courses? And the answer is yes. The first project that's more about data display and description, I've assigned versions of in a Math for Liberal Arts course, where we have a chapter 2 on probability and statistics, and our projects would be, you know, a simplified version of this, obviously not using Minitab, probably more using Excel. So that would be a simplified software, probably cheaper too if your university already has it.